to form one composite plant, and we're going to continue on with that today, a description of a few more techniques in grafting. Next week we'll move off into and describe budding, and that will wrap up our grafting. At that point we'll move on to a few other asexual propagation techniques and wrap up the semester. So as we examine a few other techniques in grafting, one of them is the bark graft. And again, this is a top working technique where you have an established plant out in the field, and there's some reason why you want to change varieties. And so you select your tree, a specific limb in that tree, take a very sharp knife and cut it at a 90-degree angle to that limb, thereby preparing that rootstock, making a nice clean cut. And it needs to be a limb that's preferably 1 to 2 inches wide. You can go with limbs up to maybe 10 or 12 inches wide, but that's not recommended with a really wide rootstock limb. It's much more difficult to heal when you have a much larger limb in that established tree. So preferably a smaller limb, maybe 1 or 2 inches in diameter. So we've made this initial cut, and now we take our grafting knife, and we're going to make one, maybe up to 3 cuts into this rootstock as a preparation site for the insertion of our scion wood. Now, if I make 2 insertions, I'm going to place them opposite each other on that limb. If I make 3, I just space them equidistant around the side of that limb. But I'm going to cut into that bark all the way down to the wood, going down about 2 to 4 inches. So that prepares my rootstock, and I would peel the bark away gently with my knife. So then I go on to my scion wood that is collected when that scion plant, the donor plant, is dormant. So back in January, February, I've gone out into the orchard. I've collected some limbs from some sticks from 1-year-old limbs, and I've typically packed them in peat moss or some other type of wet material through the winter time. And now it's spring, and I've removed them from refrigeration. I select out individual sticks that may be 4 or 5 inches long, maybe up to 8 inches long. I want to make sure that each stick has at least 2 buds on it. I want to make sure that that stick has at least 2 buds on it. That is important, remember, because those buds are going to grow into new limbs and be the branch framework of this tree. So now I've cut down my scion wood, and again I take my really sharp pocket knife or my grafting knife, and I cut into it, and I come up from the bottom about 2 inches. I cut into it, then I twist my wrist and cut down, and this creates the wedge, that long 2-inch wedge you see on one side of the scion, to allow good insertion into this cut site on the rootstock. But I'm not finished yet. I'll flip the stick over and cut out another notch on the opposite side to create this very sharp wedge that allows it to be carefully inserted. Okay, so I've got my scion piece prepared, and I insert it gently down into the cut on the rootstock. Now, that shorter stub, I want it to be on the outside, and that longer side of the cut, that longer cut needs to be to the inside, facing the wood, in other words. And this should ensure that the cambial tissue of those 2 pieces are in contact with each other, again, to allow proper healing and vascular bridge formation. Now, at this point, we need to secure it. We can use a grafting wax of some type. In some instances, very small nails, tacks, can be used to help fasten them into place so that they don't move around or blow about in the wind, especially as those buds come out of dormancy and resume growth. If you do tack them in place, again, it's beneficial to place a grafting wax or maybe, some of the pruning paint. You just want to seal off that exposed wood to prevent wood rotting organisms from gaining a foothold in that rootstock. In some instances, the grafter will, or the orchard manager, place an additional stick just tied to that limb as a bird perch. That bird perch needs to be up a little bit higher than those scion pieces. So you'll see that occasionally also. Okay, so this is the bar graft. This works well on really any type of fruit tree. It's preferred on some of the thinner barked fruit trees. So that would be like peach, plum, apricot, apple, pear. So again, bar grafting is a top working technique. Again, one of the nuances here is that it needs to be late winter, early spring when the bark is slipping on the rootstock. Remember we said the bark is slipping, that means it easily separates away from the wood. Another point to make here when we talked about the rootstocks, yes, we can go with limbs from about 1 inch in diameter up to 12 inches, but the smaller limbs are preferred. There just tends to be greater success in establishment of the graft and later success in developing branch framework of the tree with those smaller limbs. And again, scion wood collected when it is dormant. So let's see if we can
So this video is in response to a video on YouTube about rind grafting. So here I am in my orchard. I'm in Big Sur, California, and have a wide variety of trees growing all in the same spot. And I've taken a plum that had never produced very much of any plums I liked, and I've got scions off a neighbor's plum, and I've begun a graft here, which I'm going to walk you through some of the steps. Okay, so here the limbs have been cut with my good old Felco pruning saw there, folding pruning saw, and now I'll take the next step. In one-handed, basically what I'm going to be doing is making a cut down through the cambium layer here, like this. I have a really sharp knife, and I'm going to be peeling back the bark here to the cambium layer in which I'm going to be sticking the scions. Okay, so now I've made the cut, and you can see I've peeled back the cambium layer of the bark, or the bark itself, to the cambium layer, and that's exactly where the scion is going to be going. So filming this one hand is a little tricky, but you can see I've cut the scion wood there, and it's ready to place in this graft right here. So what I'm going to do is take it, and it's going to go right in like so. And I want to get it nice and deep, all the way to the same depth there as the rest. And so here's the first rind graft. And now I'm going to put the wax on. Okay, so we're ready for the wax. An alternative, I couldn't find any grafting wax, so I'm using some Harvey's No Seep toilet bowl wax. Heat it up in some water, and it works quite well. I'll show you. So I just used some regular tape that's used for supporting trees, and use that as the tape for taping up and really tightening down grafts. And you can see the wax there covering each of the 3 limbs I did of this particular tree. So that's it. That's my version of doing a rind graft. Just real quick idea of what we can grow here. Of course, we have a lot of natural trees here too, but I have everything from avocados to guavas to citrus.
So So a demonstration there on the bark graft technique. As I mentioned, this works well on thin-barked tree species, and there are, with that, thick-barked tree species. Some examples there in fruit and nut production, probably the ones you're most familiar with would be pecan and walnut. Pecan grown extensively, Texas and New Mexico, over on to Georgia. Most of our walnut production is in California. And so this technique doesn't work as well with those thick bark tree species. And so some adaptations were made by horticulturists early in the 20th century, and it received the name inlay bark graft. And a lot of the improvement in that technique was done by some Texas cooperative extension agents several decades ago, and it's received the name inlay bark graft. So it's similar to the bark graft, and again, your top working trees, established trees in your yard or an orchard. So the premise is the same. You start with a selected tree, remove the top of the limb in preparation of that root stock with a really sharp saw, 90-degree angle cut there. And again, we want to select some of those smaller limbs, maybe 1 or 2 inches in diameter. Again, we could go up to 10 or 12 inches in diameter with those limbs that serve as the rootstock. But again, the healing process tends to be slower or less success. The variation now lies in the cuts I'm making with my grafting knife. I'm going to make 2 cuts, 2 vertical cuts that are going to be about the same distance apart as the diameter of my scion piece. Okay, so I might hold my scion piece up there to get an idea of the diameter, then make 2 vertical cuts. And I'm cutting through the bark all the way down to the wood. Those cuts will be about 2 to 3 inches long. And then I carefully peel back that bark from the wood. So this is my initial step in preparation. Again, my scion wood I've collected from the desirable tree back in the winter season. I've gone up into the canopy of that desirable tree and cut out some limbs that are 1 year in age, and I've stored them. So now here it is in the springtime. I'm ready to graft, and I start selecting my wood for scion pieces, cutting them down to just a few inches in length, 4 or 5, maybe 6 inches long. And again, I'm going to take my sharp grafting knife and on one side cut in and then down to create this wedge, this wedge that's a tapering wedge about 2 inches long. I then flip it over and make another cut, just cutting out a small wedge so that I achieve a really small and tight wedge at that tip for insertion into that rootstock. And of course, I want to make sure there's at least 2 buds on that scion piece. So now I insert it carefully into the rootstock. I could tack them in place. That's not necessary. You could just wrap it up with the horticultural tape. And of course, we want to protect that exposed wood of the rootstock from drying and from wood rotting organisms. So we may take a grafting wax or some similar material and smother it to protect it during this healing process. So the inlay bark graft. This has been a variation of the bark graft that gained popularity with Texas pecan growers and pecan nurseries as early as the 1950s in Texas. So we'll take a look at this technique.
Hi, my name is Dr. Charles Rowland. I'm the pecan specialist here with the Samuel Roberts Noble Foundation, and today we're going to show you how to do a Texas inlay bark graft. and we're actually modifying it and calling it American bark graft by using duct tape. Some of the tools we'll use is just regular duct tape. You might need a set of hand pruners. You're going to need a good hand saw. I've chosen this one because it has offset blades, so it's going to cut a little quicker than some of the other saws. You need a good grafting knife. The grafting knife should have a flat blade, at least 2 to 2.5 inches long and sharp. And then finally you'll need some Elmer's glue to put on the top of your sign wood. All right, so when we're doing a Texas A&M bark graft, we're going to select a larger diameter tree. This can be done on trees anywhere from 1.5 inches up to about 8 inches in diameter. Anything larger than that, your success is going to go down because you're going to get way too much growth in 1 year, and it's a lot harder to protect that graft. So we're going to select this tree. This is a seedling, and we're going to cut it off right here between these branches, and we'll make one smooth cut, and then we'll start our graft. All right, because this tree is actively growing, we're going to make a cut on the back side through the bark, so we don't, once we cut through the tree, we don't peel the bark off the back side of the tree. So we're just going to cut through about 1/2 inch into that tree. Now we're going to cut from the front side and try to line it up with your cut that you made on the back, but it doesn't have to be perfectly in line. Now I'm just going to clean up the very tip of my cut. And now we have a place that we can put our sign wood onto. And then you're going to make one cut through the bark down. And make sure you go all the way through the bark. Then you want to peel it back just a little bit. You want to cut the very tip of your sign wood to remove the dried portion of the sign. And then we're going to make our cut using our pocket knife. We're going to make our cut about 2.5 inches long. And I'm going to remove this bud as I'm cutting. And you want to start straight into your wood and then twist your wrist so you're cutting just through about half of the diameter of the sign wood. You're going to have a nice flat piece of wood that you're going to insert into your rootstock. After you make your front cut, you're going to make a small cut on the back side just to expose the cambium layer. Then you're going to line your sign wood up with your first cut that you made on your trunk, and you're going to cut right down the side of your sign. And then you're going to peel the bark back just a little bit so you can start your sign wood in. And once you start feeling it's being a little snug, use your end of your pocket knife and tap it down so that flat piece is snug and then this beveled edge is still sticking above your rootstock. Okay, now we're going to use our duct tape to secure this graft. We're just going to pull that tape fairly tight around and over your cut you made on your rootstock. And then we're going to just push the exposed part down. And then we will use additional tape on top just to cover the top of our cut here to keep it from drying out. And then one last step, I peel half of my duct tape in half. And I'll put a little ribbon around the front here. And if you're doing multiple varieties, you can use different colors so you can identify what variety you've grafted. And this is going to cover up the back portion of that sign wood that you left exposed. And And then one last step on your sign wood is to use your Elmer's glue. Just apply it to the tip to keep it from drying out during the heat of the summer. The last step is to put a bird perch. You just remove a branch that you cut off the tree, and we're just going to tape it so it's taller than our sign. So whenever a bird lands, they're going to kick off of our bird perch instead of our sign, our graft union here. And then you're done with that graft. This is a inlaid bark graft that was applied 2 years ago. You can see where we cut the tree off right here. And right here was our original piece of sign wood. And so you can tell that the tree has grown quite a bit in caliper. And we have a new start on our new variety tree with this graft.
Very good. So there's a demonstration or a modification of the inlay bark graft. It's been quite popular with pecan growers.
Dick, for a larger caliper rootstock,
All right, just a minute
we
here.
use the bark grafting method, correct?
That's correct. Any tree that's about 1 inch up to about 4 inches in diameter would.
And another example of an inlaid bark graft on a pecan tree. This is in the second year of growth, and this is in a homeowner's backyard in the Dallas area. Just a existing tree seedling served as the rootstock, grafted on an improved variety. And then there's a piece of bamboo attached to this developing branch to keep it from breaking as those high winds kick up in the springtime. And it also serves as a bird perch to further protect it as it develops and gains strength each season. Okay, moving on with another type of graft, and this is called the approach graft that I want to mention to you, where you typically have two existing plants that continue to grow independently during the grafting process, and most often both of them are in containers, or maybe just one of them is in a container. The approach graft, two plants placed side by side, and we wound the stems of both plants and bring them into contact with each other and let a healing process begin, and thereby the graft union is formed. So two independent plants are grafted together. We only separate those two plants after that graft union has formed. So that may, of course, take several weeks. Typically, both plants are in containers, or maybe just one plant is in a container. We see this used in nurseries sometimes where they have limited numbers of plants, and maybe it's a plant that doesn't root well when we take cuttings and place it under mist. So an alternative is to perform an approach graft. It's not a common technique by any means, but nonetheless it can be at the disposal of a nurseryman in some special circumstances, or used by a home gardener. So just the concept here is we have two plants, and one's going to serve as the rootstock. And of course, one serves as the scion piece because it has preferred foliage characteristics, preferred fruiting or flowering characteristics. And the stems are placed in contact with each other. And first, a wound is made. You might take your knife and cut off a section of the side of the stem that's 1 or 2 inches long. And do that on both plants and place them into contact with each other at that wound site. And use some type of adhesive material or horticultural tape to fasten them together. So then it goes through this healing process of vascular bridge formation, and then cuts are slowly made after the healing process. And typically, on the right there, the scion piece would be removed first. So just beneath that graft union, I cut it away. Now, that potted plant on the right that's serving as a scion, again, it's not thrown away. It still has value. It's going to rebranch and have a flush of growth, and it could be used as another source in another approach graft. So coming back to the plant on the left now, it is healing. And again, I want the top of that plant to be this preferred scion piece. So I'm going to cut away the top portion of that plant that serves as the stock plant, and thereby focus all the top growth on this new attachment from the scion plant. So again, approach grafting used when I have limited number of scion pieces and maybe they don't root well when I take cuttings. The approach graft. So we've talked about some techniques of grafting that we apply to fruit and nut trees. Over the last 15 or 20 years, there's a gaining popularity in grafting vegetables. You know, think of vegetables as this seasonal crop. They're annuals, herbaceous plants. And this seems like grafting is a very sophisticated, laborious technique, and we're going to place this into this very short-term crop. The rationale there lies in that, wow, there's a lot of effort placed into breeding plants to improve their characteristics, from their fruiting qualities to disease resistance in the foliage, but then also the root characteristics, breeding disease resistance into the root portion of the plant, or maybe resistance to salt-affected soils or some other soil condition. Thereby, with plants like cucumbers and melons and tomatoes, the breeding work has gone not really in two directions, but it's separated there, where we breed improved rootstocks, and maybe the fruits aren't preferable. And then on the other hand, we have breeding going on to improve the upper portion of the plant, the scion piece. So vegetable grafting, it's been popular in hydroponic vegetable production also, but it's catching on also in field production of vegetables. And it's a very rapid and simple technique. You know, you have one seedling that's serving as a rootstock. So if you look at the 3B, the upper left corner, the plant on the left serves as the rootstock. Again, it was chosen because it has, again, this is cucumber. The rootstock was chosen because it has some resistance to a soil-borne disease. We're going to graft onto it a plant that has preferred fruits but doesn't have that disease resistance in the roots. So I'm using a razor blade or some very sharp knife to make some simple cuts at about a 45-degree angle in the stem. I first want to make sure that the two seedlings are about the same age, or at least the same diameter. Remember now, these are not woody plants. They don't have a cambium layer. Okay, so the healing process and vascular bridge formation, just a little bit different. Nonetheless, it's the same, that you're establishing this continuity in the xylem and phloem tissues. So as you see here, the cuts are made, they're joined together, and we have to have some material to help fasten them together. You can take a small section of polyethylene pipe and slice it, use that as the material to hold it together, or a piece of foil or a piece of plastic. Just a material that's not going to cut into this soft tissue, yet still hold them close together. And the healing process, much more rapid compared to their woody plant counterparts. So here, after 10 to 14 days, we should have a successful graft union. And if you look now at the bottom 3D, after that has healed, the plant on the right will be cut right beneath that graft union, and the plant on the left will be cut just above that graft union, thereby creating this grafted plant, which then is set out into the field. We have developed machines that will perform this graft for us. And it just takes a couple of workers to essentially load the two types of plants into the machine. And through automation, it loads them in, cuts them, places them in contact with each other, wraps it up. And then on the other end of the machine, the other person handles the grafted plant. So there is some automation that goes on with this. We've developed some specific machines capable of performing this technique accurately and rapidly. So let's see here. So some examples of vegetable grafting. As I mentioned, it's good to start with two pieces that are about the same diameter in both rootstock and scion piece, and we sever it away with a very sharp knife or razor blade, and you need to have about a 1-2 inch stub there. And we've taken a short piece of polyethylene pipe, we've split it, and this is going to serve as that fastener, so to speak, after we've performed the graft. And we're making a second cut there. So now we go and prepare our scion piece. And they are joined together. So this is a demonstration of grafting vegetables, and again, it's become popular with melons, cucumbers, tomatoes, whether they're grown in the field or hydroponically in a greenhouse. Here we see some small grafted tomato plants out in the field. Or in high tunnel production. And again, the value there to the grower is, yes, they have this additional cost of a grafted plant, but there's less plant loss out in the field, a significant reduction in the amount of chemical pesticides applied, especially fungicides, and with more and more emphasis on integrated pest management, that's where the future lies in terms of controlling pests and preventing pest damage. Okay, so back now to our presentation. So that's just a very simple technique, and again, the healing process, 10, 14 days typically in these annual plants. And again, just, we've looked at this before. We may also use grafting out in the field to repair damaged plants. It might have been damaged by a piece of equipment or by an animal. And we're, again, restoring that continuous flow through the xylem and phloem above and below the location of that damage. So this brings us up to the end of our grafting techniques. And again, next week we will go off and describe the various techniques of budding. Have a good day, everybody.